look at this one as a proportion. So the area of a sector, which is the pi piece that's formed from a circle, area of a sector, the area of a circle is pi r squared. The area of the sector we usually reserve for the variable k, and that's going to be equal to the amount of theta, amount of angle in your central angle, out of the total amount of angle inside of the entire circle. I'm leaving the word as total right now because total depends which mode you're in. In radian mode, your total amount of radian measure in a circle is 2 pi, and in degree mode, the total measure of degrees in a circle is 360. So in the problem on the left, it says the sector has area 10, so k is 10, over pi. The radius is the question, right? What is the radius? So that's going to be an r squared located right there, equals the angle measure is given as 3 pi over 5, and since this means you're in radian mode, that means that the total is going to be a 2 pi. So that sets us up with a fraction, a proportion here of a ratio equals a ratio. So cross multiplication, 10 times 2 pi means 20 pi equals, multiplying the other way across, we get 3 pi squared over 5 times r squared. So 20 pi, 3 pi squared, 5 r squared. Now I'm just going to grab my calculator for this calculation because I'm going to have to divide both sides by 3 pi squared over 5. So in my calculator I'm typing in 20 pi, which is the left hand side, and then I'm dividing by, grouping it in parentheses, 3 pi squared over 5, and if we've done this correctly, hopefully we got an answer of 10.61, and so when we want to find r, we're going to take the square root of that, and the square root of that is 3.26. So the radius in this problem would be 3.26. Okay, on the right, let's see what happens. The radius is given as 5. We're looking for the area of the sector, so k over pi r squared, where radius is 5, is going to be 25 pi, equals, and the central angle is 50 degrees, so that means our bottom number this time is going to be 360 degrees, because this time we're in a degree mode. So, multiplying both sides by 25 pi, I can see some cancellation here, and it's going to leave me with k equals, see on the right hand side we have 50 multiplied by 25 pi being divided by 360. So if you're following along at home, hopefully on this one you got 10.91 approximately. That's rounded to the nearest hundredth place. So I think that's worth it. Why don't you try to do one on your own here? Pause the video and see if you can find this answer. The radius of the circle is 6 and the area of the sector is 75. Find the central angle. Now I purposely left this one open. If you notice, I didn't tell you whether it was radian or degree mode so that we can do both radian and degree mode. So on the left, area of the sector is 75. Area of the circle, since the radius is 6, is pi r squared. That's 36 pi. That's going to give me an angle out of an entire circle, and the entire circle in radian mode is 2 pi. So to isolate theta here, we're going to multiply 2 pi on both sides, so that way we cancel. And theta would be equal to 2 pi times 75 divided by the quantity 36 pi for 4.17. Now if on the other hand you decided you wanted to do a degree mode, then what you would have been performing for degree mode would have been 75 out of 36 pi, because the sector didn't change and the circle didn't change, but this time you'd be saying theta out of 360. And so when you isolate theta, you'd be multiplying by 360 instead on both sides, and your theta is going to come out in this case to be 360 times 75 divided by 36 pi. So on this side it would be 238.73 degrees. 238.73 degrees.